Okay, optimization questions. We just finished a lesson working with the volume of a box, and so I wanted to kind of go way different and talk about, something that was much more abstract so that we could see different things and make sure we all fit in before the end of the class. This is only a 7-pointer, but it's got the exact same workflow as the other one did. We need to come up with a formula, take the derivative, and set it equal to 0. This says, the following diagram shows the graph of the function. Okay, well that's going to be important for sure. On the interval from 0 to 2 pi, I'm not sure that's going to be that important really, but maybe it could be important. The vertical line, a vertical line segment AP is drawn between the horizontal line and y equals 5. That sounds like that's going to be important because those are my two things there. Okay, and the curve y equals f of x, make sure where a is on y equals 5 and point P is on the curve I showed above. Okay, so basically we have y equals 5. We have a sine graph with a vertical stretch and it's up 2, but who cares? And we're just trying to basically draw a bunch of lines, boom, 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 boom. And we're gonna come up with a couple things. Find the minimum and maximum value. So basically, when I draw those lines, where is it closest, these two things, and where are they furthest, those two things. Now, honestly, just looking at this graph, you can come up with the answers, like realistically. What is the furthest that these two graphs are away from each other? What is the longest line L as I draw from here to here to here to here to here to here? What's the longest line that we get? 5. Yeah, right? I mean, boom, there it is. 5. You're right. That is, L is the longest length is 5. And what is the shortest? Just one. But obviously, when you get to the IB test, or even on any kind of calculus test or R test, you can't just look at the graph and say, "Yeah, it looks like 5." The answer is 5. Let's actually do what it says here and find those values mathematically. Explain why the length of L of AP, length L of AP, is given by L equals 3 minus 2x. The way that they're doing these questions is they're trying to walk you through that process. And so they're trying to help you find your formula by basically giving you the formula and asking you to why is that the formula, okay? If we're trying to find our formula for how far apart these two things are, it's pretty simple. You start with one and you subtract the other, right? You just do A minus B. And so if we set that up, L is equal to A, which is the top formula, which is super easy, 5, and then we just subtract the bottom formula to take it away, which is 2 sine x plus 2. And then of course, we have to subtract, and we want to make sure that we distribute it. So it's actually not 5 plus 2, it's 5 minus 2, and that's why we get 3 minus 2 sine x. And there we go. Part A, it's a little 1-pointer, it's done. You just take the 2 and subtract them, it's not too bad. So getting this question set up into finding that formula really wasn't very tough. They really basically walked us through it. Part B says find the minimum and maximum value of L by using the differentiation of L. Again, they're basically walking you through this process. The same steps we said before. We found it, time to take its derivative and set it equal to 0. So, what is the derivative of L in respect to x? Should be pretty easy. You guys tell me. The derivative of 3 is 0. The derivative of sine is cosine. And when we have negative 2, it's just a coefficient. So negative 2 cosine x. That's the derivative. And with every single one of these, that derivative is useful basically just to show that where are the stationary points. Set it equal to 0. Okay, if we set it equal to 0, well, this 2 just kind of evaporates because we can divide both sides by 2. Who cares? Where is cosine equal to 0? Do you guys know those values from the unit circle or from the graph of cosine? Cosine looks like this. At 0 it is 1, at 2 pi it is 1, at 1 pi it is -1. It is in between 0 and a pi where we have the 0 value. And so that is going to be at pi halves. That would be x equals pi halves. And we get another one over here at 3 pi halves. Now, make the formula, take the derivative, set it equal to 0, find if it's a max or a min. So let's do that. I'm going to probably consider the second derivative. In order to do that, the d squared L over dx squared is equal to the second derivative we've got so many. What on earth? Oh, I think I cloned. Alright, try to be cute for 1 second. I don't know. Okay, take the derivative of the derivative. That would be positive 2 sine x, because the derivative of cosine is negative sine, 2 negative is positive. Okay, cool. Then I'm going to plug in those values. So 2 sine of pi halves. Sine looks like this. Pi halves, the sine value is 1. 2 times 1 is 2. So this is positive, which is giving you a concave up, which is giving you a minimum. So this value right here is a minimum. 2 sine of 3 pi halves, which is right here, which is -1, is going to be -2. So that's going to be negative. That's going to be concave down like that. That's going to give you a maximum. So this is a max. Okay? Let's look at this whole thing for just a second. That is exactly what we already knew. We already knew that, okay? We already knew that the minimum at pi halves, this is the minimum right here. And we know that pi is like 3.14. Halfway of 3.14 is like 1.56 or whatever, 1.57. And yeah, exactly what we thought. That is when we have the minimum length L, and the maximum length L is at pi and another half, or 3/2 pi, which is another 1.57, whatever, past. Cool. Now we found all those things, find the minimum and maximum value of L. Remember that last step was the actual answer. We found where the minimum was. We found where the maximum was. But did we ever actually find the true minimum and maximum? Not yet. So in order to find those true maximums and minimums, I'll just write it over here so I can write it big, we can be done. We're going to want to use L and plug in these different places. The minimum at pi halves would be 3 minus 2 sine of pi halves. We already said that sine of pi halves is 1. 3 minus 2 times 1, which is 3 minus 2, which is 1. So the minimum of L is 1 at x equals pi halves. And the L maximum is equal to, let's change this to a 3 pi halves, and the 3 pi halves is where it is -1, and 3 minus 2 times -1 is 3 plus 2, which is 5. At x equals Now we have just crushed this problem. We have found everything there is to find. Where is the x value? What is the length at that x value? Is it considered a maximum or a minimum? A lot of times, students, we work so much with the shape questions and the volumes that these ones like scare students, but I actually think these are the easiest ones, right? You come up with your formula, you take the derivative, you say it's not too bad at all. Okay, let's do one more. Let's do a shape one, because we already did that one. This one says a rectangle has sides x and y. The last one says a shape under a graph. Which one looks hardest to you guys? 2, 3, or 4? I would guess 4 probably looks hardest. Honestly, the shape looks kind of crazy. Probably, okay. Let's do the 4. Okay. Let f of x equals 80 minus x power 4. That is this piece. A negative 4th power is a negative even function, which means it's a downward shaping w or u. And so that's that piece. That's going to be important. We're going to want to use that. And rectangle ABCD is inscribed between the region of the curve. Okay. Okay, assume the lower vertices. Okay. Negative a, positive. Okay, so what this is telling us is that, of course, if we go right and left, it's going to be the same amount because it says negative a, positive a. Let me zoom in a little bit. Not like that. I got to do it like this. That's as far as we're zooming in, I guess. Okay, so all of this. First thing that I'm seeing that's definitely going to be important. Let's see if I can make this big so I have a little bit more zoom. Okay. Definitely, I like this. Okay. I'm definitely going to need that. For the other question, we had the line and the curve. For this question, we have the line and the box. So let's talk about the box for a second. Do we get any equation for a box? No, because there's not really equations for box on a graph. But we can come up with the dimensions for the box. Because they're talking about the area of the rectangle. Okay? So our area of this rectangle could be x times y, right? That's pretty simple. But maybe we make this even a little bit smarter because we know that this box is like symmetrical. So I think it's easiest if we think about this as like x times y, but then we like double x. Does that make sense? Instead of having to calculate x as being the whole thing, because whatever this value is here, this is going to be the value x. And then whatever that value is, let's say it's 2, then the box will be 4y. Or let's say that value is 1, the box will be only 2y. Now, just like the box that we made, obviously this box is drawn here, but the way this question is working is if your x value is 1, then your rectangle would look like this. Or if your x value is 2, then your rectangle would look like this. And so they're saying, which of these rectangles has the biggest area? It is definitely not obvious to me, which that would be just by looking at this. There's a huge variety of different shapes that we could be. Okay. Show that the area of the rectangle is given by S equals 160a minus 2a power 5. I think we pretty much already did this, okay? For a letter A in black, for letter A, we know that the area of this rectangle, which they're wanting to call S, is equal to x times y, and I think it's best if we do it like this, 2xy.
Good morning, Jesus.
Good morning.
Please take the next few minutes to allow your students to sign up for the college fair if they are interested in attending. Thank
Now,
you so much.
they want our S to look like this, which is a lot more complicated than x x squared y. But it's only a little tiny bit more complicated, okay? The reason it's only a little tiny bit more complicated is because they already told us that this curve, which we knew was going to be important, is 80 minus x power 4. And are you seeing the resemblances between 80 minus x power 4 and 160a minus 2a power 5, right? This is the y value, because whatever our x value gives us for the box, I think this thing just froze. Our y value is going to be the one that comes from the curve. So we're going to swap these out. 2x 80 minus x power 4. And then there's our exactly what we wanted. 160x minus 2x power 5. So again, it's the same process. We need to make a formula. In order to make that function, we're probably going to need to use two things and do a substitution. It works like that every time. The next part is...
Teachers of traffic interruptions. If for some reason your students are having trouble signing up for the college fair due to the one login issue, please put...
We're going to do the derivative. The derivative of s in respect to... Let's just keep it with x's, whatever. It doesn't really matter. 160 minus 10x power 4. That's a very easy derivative. Set that derivative equal to 0. 160 equals 10x power 4. Divide both sides by 10. Just 16 equals x power 4. Take the fourth root of both sides, and we get x equals positive or negative 2. Now, what does that mean, right? We found a lot. What we just found is that on this graph, we are not looking at the biggest rectangle, because the biggest rectangle would be an x value of 2. And then whatever y value that is, and that would make our rectangle. That is the biggest rectangle that you could possibly make. Out of all the values, that is the biggest one. But what is the actual question that they said? Find the maximum value of s and justify it. So we haven't answered either part of that question yet. Find the maximum value of s. S equals 160 times 2 minus 2 times 2 power 5. That's just me plugging the 2 into the s to figure that out. S equals 320 minus 2 power 5 is 32 times 2 is 64. 320, 64, that would be 256. Is that a maximum or a minimum? Let's take the second derivative and see if we're concave up or if we're concave down. D squared s over dx squared is equal to, well, that's easy. The 160 is going to go away. Negative 40x cubed. Okay, if I plug in a 2 here, I don't really know what that number is going to be, but it's definitely going to be a negative number. 2 cubed is 8. 8 times 40 is, it's going to be negative 320. Who cares? It's a negative number. So because it is negative, it's going to be concave down, which is going to be maximum. find your equations, find your functions, take the derivative, set it equal to 0. Hopefully it feels like once we get to the derivative part, it happens very fast. Derivative equals 0, find the number, plug the number in, check if it's a maximum or a minimum. It's all pretty quick. All of the like heartache for me is in this first step of coming up with that formula and figuring that out.